Okay, so Leetcode practice time. So in this video, two things. First one is to see how to solve this problem, and then we are going to put some solid code in, and then another thing is to see how to solve this problem during an interview. So let's get started. So the first step is to understand the problem and try to ask some clarification questions in case there is anything that is unclear to you, and also at the same time think about the edge cases. So let's see. Insert into a sorted circular linked list. So given a node from a circular linked list which is sorted in ascending order, write a function to insert a value which is called insert value API into the list such that it remains a sorted circular list. And the given node can be referenced to any single node in the list, okay? And may not necessarily be the smallest value in the circular list. And if there are multiple suitable places for insertion, you may choose any place to insert the new value. And after the insertion, the circular list should remain sorted. And if the list is empty, you should create a new single circular list and return the reference to that single node. Otherwise, you should return the original given node. So if the list is empty, we just create a new node and return it. Otherwise, we return the original given node, okay? Yeah, I think we are pretty clear. And let's take a look at this example. For this one, we insert 2, then we are going to insert it between 1 and 3, and then finally we return original node, which is 3. Alright, so I think we are mostly understand what the problem is asking us to do. So I would say one edge case definitely is, suppose the list is empty, then we need to create a new node and return it. And the other thing, I think, suppose for example, suppose the list is something like it contains 1, 3, 5, and 7, and it is pointing to 3. Suppose it is pointing to 3, which is this one, and we are going to call, let's say we call insert 2. Then what are we going to do? So we can get the current pointer and the next pointer, and keep moving until we hit the 1 3 1 3. So suppose we have two pointers, so the previous pointer and the current pointer. So we keep moving until we find a suitable place to insert the 2. Ooh. And then next time we are going to, current pointer is pointing to this, and the previous pointer is pointing to this, and then we insert the 2. So what if we we are going to insert 8. So if we insert 8, we see that the previous pointer is going to be 7, and the current pointer is going to be 1. So of course 8 is larger than 7, but 8 is also larger than 1. So I would say that is a place that comes to the end of this linked list. So we are going to insert it here. Let's see if there is any other. Okay, so there are two cases. One is to insert the node in the middle, and the other one is to insert the node at the end or at the beginning, which is the same, which is of the same concept. So okay, so I think we kind of get it. And the other thing, so if it is, so suppose I insert, let's take another look. Let's say suppose we insert a 0 here. when previous pointer is this and the current pointer is this, then we say, okay, we are going to insert u here. Okay. Okay. And let's see, suppose there is only one node. Suppose there is only one node, which is called 1, and we are going to insert 2. What are we going to do? So if we insert 2, we will see that the previous pointer and the current pointer both pointing to the same thing. So I would say, okay, so I would say the time we are, okay, so we need to have a limitation about when to stop iterating, like, because if we encounter the current pointer again, it means we have already visited the circular linked list once. So that's the time we need to pretty much stop and just insert the 2. So in this way, we don't need to, we will not like we will not get a that loop here. Okay, so several different cases. One is to insert in the middle, the other one is to insert at the very beginning or the end, and the last one is if we hit the current pointer, the head pointer again, then we need to just insert the node there. Okay, so that's the plan. So that's pretty much about the solution, and after that we are going to do some coding work on the top of this. So in here we care about your speed and also the readability and of course the correctness of the code. So let's get started and do some coding work here. And of course after the coding part we are going to do some testing. So first of all, which is one edge case, if head is equal to a non-pointer, what we are going to do is we are going to say, okay, node, we are going to create a new node, which is node is equal to new node. Okay, and we are going to insert, okay, the insert value. Okay, and node dot prev dot next is equal to node, and we just return node. Okay, that's the edge case, and the other one is we will try to see we will iterate through this the circular linked list to see to find the position to insert the node. Okay, so let's see, if it is inserting a 2, then so okay, so first of all we need to define 2 pointers. The current, so the first one is a current pointer pointing to the head. Let's say, okay, so let's see, it is, let's say, call it this previous point, let's call, okay, the current pointer, and the next pointer is equal to head, and the next pointer is equal to head dot next. Okay, so well, we need to set a stop condition. So suppose we encounter the current is equal to head again, then that's the time that it, so that is so that's the condition we need to stop. So how, so if, let's say, if we set current is equal to head as a condition, then there might be some issue because we cannot really start it. What about next is not equal to head? So if it is next not equal to head, if it is equal to head again, so let's say, okay, so let's see. So what we could do is like something like this. Okay, so if insert value is larger or equal to is larger or equal to head dot value, and insert value is smaller or equal to head dot next dot value, then it is time we are going to do the insertion. So we are going to say, okay, head dot next is equal to new node. So head dot next is that one, and it is insert value. Okay, and we just need to return. Okay, and then let's say current is equal to head dot next, and next is equal to next dot next, and in this way we can successfully jump into this while branch. Okay, so like this one, so let's say, because there are several conditions, let's say we have boolean to insert is equal to false. So let's say if like the condition below, if insert value is larger or equal to current dot value, and the insert value is smaller or equal to next dot value, then it is the time we need to do the insertion. So we are going to say, okay, to insert is equal to true. So if if current dot value is larger than if this one is larger than next dot value, then it means it is a place which is the beginning of the beginning, or the edge among the beginning. It's an edge between the beginning and the end. So what we need to do is we need to take special care about this. So if insert value is larger or equal to the current dot value, or the insert value is smaller or equal to a next dot value, so we can also do the insertion. So you'll see the to insert is equal to true. So if we need to insert between the current node and the next node, if this is true, what we would do is we would just say, okay, so current dot next is equal to new node insert value, and then it is next. Okay, all right. So and then if we have already done the insertion, we just return the head here. And like we said, suppose there's only one node, or maybe everything in the list is the same, then that's when we encounter the head node again, and we just insert it at whatever the place it is, and it's just fine. So current.next is equal to new node, insert value next, and we are going to return head. All right, so let's double check, which is the testing part. So the testing part, we are going to do some sanity check by going through this code using some example, and at the same time we will explain it, and the next one is to set up some different test cases to have good enough test coverage about different cases. So let's take this example. Let's say we have the 1341, and then it is pointing to 3. So let's say at the very beginning, okay, so let's give it, so we have 1, 3, and 4, and this is the current pointer, and this is the current pointer, which is 3. Next pointer is 4, and we do the, and we see, okay, if we insert 2, it is not going to fall into this if branch. So we are jumping into this else. So we are going to set current as equal to this one, and next as equal to 1. And then, well, we are going to jump into this while loop. So, okay, and make sure that the head node is 3. Okay. And so insert value, since this is, so the current value is dot well, it is going to be larger than next wall, because 4 is larger than 1, so it is an edge between the end node and the one and the begin node. So because the insert value it's not larger than the largest one, and it's not smaller than the smallest one, then we are not going to set to insert as true. So instead, we are going to move the pointers. So we are going to move the next pointer, we are going to move the current pointer, and now we see it's going to jump into this if range, and we set to insert as true, and we are going to insert it properly, and set the linking relationship. Okay. So this one it should work. Let's say if we insert a 5 here, so if it is a 5, similarly, when the current pointer is this, and the next pointer is pointing to the beginning, we see that the insert value is larger than the ending number, so we are going to insert it there. And let's say if there is only one node, let's say if it is 1, and we are going to insert 2. So this one, of course, it's not going to work. And then we jump into this while loop, and since the current is equal to head, then we directly jump out of this while loop, and we are going to do the proper thing, inserting this node, the new node with value as 2. Okay, so I think it should work. Let's give it a shot. Okay, so okay, so it's the typo. Okay, and then we return where? Okay, so it should be returning head. Some typo. So next is equal to current.next. Okay. Alright, so quite some typos. Let's see. Oh, time exceeded. So actually we didn't move the pointers, so it should be current is equal to next, and next is equal to next.next. Okay, so it should work. Okay, now it should work, and I think it should be good. Okay, so it's accepted. So like I said, definitely set up some test cases, like the example 1 and example 2, and also for example 1 we can insert 5 and insert 0, which is like inserting after the ending point or before the beginning pointer. And also think about if there's only one integer, then how it is going to work. Like it is going to test this branch. Alright, so that's it for this coding practice. I hope you like this video, and I'll see you next time. Thanks for watching.